Alright, in this video here we're going to talk about the inverse sine function and really just do some examples evaluating the inverse sine function. Right? So if you haven't seen the other video that I did where I explained what the inverse sine function is and the definition of it and how we figure out what the graph looks like and all that, definitely check out that video before you watch this one, because that one explains in a lot more detail what the inverse sine function is all about. This one we're just going to focus a little bit more about how do we use it to actually get answers to problems. Alright, so I put up here the unit circle and just the right half of the unit circle. When we're using the inverse sine function, we only need to be concerned with the right half of the unit circle. Right, now a quick explanation of why that is. Again, if you watch the other video that I did, I kind of talked about this in more detail, but I'm just going to go through it quickly here so you understand why we're only using half the unit circle. Remember, for the sine function, in order to create an inverse sine function, the graph of the sine function had to be 1 to 1, which means we had to limit the domain just between negative pi over 2 and positive pi over 2, right, so that the sine function hits all the y values between negative 1 and positive 1 that the sine function covers, but it only hits each one of those y values one single time. Right? That's what makes it a 1-to-1 function. For each x there's one y, for each y there's one x. Right? So since it's now a 1-to-1 function, when we limit the domain, that allows us to create an inverse sine function. Right, so when we're doing the inverse sine function, basically what we're doing is, they're giving us the y value here. So they're giving us a number in between negative 1 and 1, and we have to find the x value for the sine function that gives us that y. Right, remember, inverse functions switch the inputs and outputs. They switch the x's and y's. So when I'm evaluating an inverse sine function, they're giving me the y coordinate and asking me to find the x coordinate. Well, the y coordinate, like I just said, is always between negative 1 and 1. But since we had to limit the domain of the sine function between negative pi over 2 and positive pi over 2, that means that the answer we give for an inverse sine function has to be between negative pi over 2 and positive pi over 2. Right? It has to be part of that restricted domain of the sine function that made the function 1 to 1. Right? So the key thing to know when you're doing an inverse sine function is, our answers have to be in between negative pi over 2 and pi over 2. They have to come from this one little stretch of the graph of the sine function where we limited the domain. Right? So what that means in terms of the unit circle, well, pi over 2, well, first of all, 0, right? So 0 is right here on the positive x-axis. Pi over 2 is up here on the positive y-axis. Negative pi over 2 is down here on the negative y-axis. Right? So, and then in between, or on that right half of the unit circle, we hit all the y values from negative 1, which corresponds to this point on the graph down here, right, to negative root 3 over 2, negative numbers up to 0, which corresponds to the point at the origin on the graph, and then positive y values going up to positive 1, which corresponds to that point on the graph up there. Right, so just that right half of the unit circle, we cover all the values for the sine function, all the output values from negative 1 up to positive 1, and we only cover each one single time. Right? So when you're doing an inverse sine function, you're never giving an answer from the second or the third quadrant. Right? It's always coming from the right half of the unit circle, from quadrants 1 or 4. But when you give an answer for quadrant 4, you have to give it as a negative value. Right? Because remember, the graph was from negative pi over 2 to positive pi over 2. So we don't think of this point down here, when we're doing inverse sine, we don't think of this point down here as 3 pi over 2. We think about it as negative pi over 2. Right, and then the other ones, if you're not sure what they are, they're just reflections of the ones up above. And remember, if you remember how to use the trig hand that I did a couple videos on, and if you don't remember that or you haven't seen it, check out the videos I did about trig hand and about filling in the unit circle, so you're able to do this quickly and efficiently. But if the first one up above here is pi over 6, the first one down below is negative pi over 6. Right, the one in the middle is pi over 4. The one in the middle down here is negative pi over 4, and then pi over 3. Negative pi over 3, pi over 2, negative pi over 2, right? They're direct reflections of the ones that are up above, right? So it shouldn't be too hard to figure out. And then all the terminal points down here, right? The ones in the first quadrant you can get from your trig hand, and then when you put them down in the fourth quadrant, you just keep the x positive and make the y negative, because in the fourth quadrant, any point you have in the fourth quadrant has a positive x and a negative y. All right, so that's an explanation of why we're using just the right half of the unit circle, and why when we're in the fourth quadrant, like my answer to an inverse sine problem is this point right here, I don't call that 11 pi over 6, I call it negative pi over 6 when I'm dealing with the inverse sine function. Because again, inverse sine has to be from this stretch of the graph in between negative pi over 2 and positive pi over 2. Right? Hopefully that makes sense to you. I've had students in the past get confused about that is, well, why do I have to use negative values instead of just the ones I get from going around the circle this way? And it's because, the graph I just had up here, that stretch of the graph is just between negative pi over 2 and positive pi over 2. So we have to consider these points in the fourth quadrant as negatives instead of, going all the way around this way with positive numbers. All right, so that's that quick explanation. That wasn't that quick, that was more than 5 minutes, but of why we're using the right half of the unit circle and why we use these as negatives. But it's really important to understand that so that when you evaluate the inverse sine function, you do it correctly. If you understand that part of it, then when we do these examples I'm about to put up here for the inverse sine function, it's really easy to do. All right, so I'm going to pause this real quick and put up a couple problems, and then I'll play it again and explain how to do this. All right, so the first few examples up here, we have sine inverse of 1/2, sine inverse of negative 1/2, sine inverse of 3/2. All right, so remember, when you're doing the inverse sine function, it's like this. So for sine inverse of 1/2, basically what we're asked is, sine of what number is going to give me the output of 1/2? Right, remember, inverse functions switch inputs and outputs. So the input for the inverse sine function, the 1/2 in this case, is the output for the sine function. So the sine of some number is going to give me 1/2. Right, so when we're doing the inverse functions, not just inverse sine, but for any of the inverse trig functions, they're giving us the output value. They're giving us the point from the terminal point on the unit circle, and we're looking for the pi number, negative pi over 4 or pi over 2 or whatever, that gives us this output. Right, so our answers for most of these inverse sine problems is going to be one of those pi numbers that we should know from the unit circle. Right, so knowing the unit circle, really important to be able to evaluate these correctly. But if you know the unit circle well and you're able to fill it in pretty quickly, finding sine inverse of 1/2 is not so bad. All right, so the sine of what number gives me 1/2? Well, remember the definition of the sine function, the sine of the input value gives me the y coordinate of that terminal point. So when I'm doing sine inverse of 1/2, basically what I'm doing is I'm looking around the right half of the unit circle. Right, remember, for the sine inverse function, it's only the right half of the circle, and I'm looking for, since it's sine, where's the y coordinate? 1/2. All right, so I go around the unit circle, the right half of it, y equals 1/2, right here. Right, which is at the value of pi over 6. All right, so sine inverse of 1/2 equals pi over 6. Right, again, the inverse function is switching the inputs and outputs from the regular sine function. Right, sine inverse of 1/2 equals pi over 6 because sine of pi over 6 equals 1/2. Right, switching the input and the output. Right, sine of pi over 6, sine gives me the y coordinate, which is 1/2. Now you might be thinking, well, but there's another point over here that also has a y coordinate of 1/2, which would be 5 pi over 6 if you're interested. But so why is that not also one of the answers, 5 pi over 6? Right, remember, for the inverse functions, we had to limit the domain so that we only get one answer. Right, the definition of a function is that when you input one value, you only get one value out of it. Right, so sine inverse of 1/2 is only pi over 6, even though there is another number over here on this side of the unit circle that also has a y coordinate of positive 1/2. That's not part of the domain and range of the inverse sine function. Right, the domain and range of the inverse sine function tell us only use that right half of the circle. Right, so real important to know that for inverse sine, we have to limit our unit circle usage to just the right half. Right, just between negative pi over 2 and positive pi over 2. All right, so sine inverse of 1/2 equals pi over 6. Next one, sine inverse of negative 1/2. I do the same thing. All right, so sine inverse tells me right half of the unit circle. Sine tells me I'm looking for the y coordinate, and I'm looking for a y coordinate of negative 1/2. All right, well, if the y coordinate is negative, I already know it's going to be in the fourth quadrant, right? Because the ones in the first quadrant up here have positive y values. So negative 1/2, well, that's right there. All right, that's where I have a y coordinate of negative 1/2, which is at negative pi over 6. Right, so negative pi. Now remember, it's not 11 pi over 6, right? The sine of 11 pi over 6 also gives you negative 1/2. Right, but when we're doing the inverse sine function, we have to treat these values in the fourth quadrant as negative values because of that graph that I had up over here before, going between negative pi over 2 and positive pi over 2. So it's another key thing to remember, these ones in the fourth quadrant, it's not 11 pi over 6, it's negative pi over 6. Right, and this is the case because the sine of negative pi over 6 equals negative 1/2. Alright, so again, inverses switch the inputs and outputs. Next one, sine inverse of 3/2. Alright, so sine inverse tells me I'm looking at just the right half of the unit circle. The sine here tells me I'm looking for just the y coordinate. So I'll go around the y coordinate and I'm looking for y coordinate of 3/2, not square root of 3 over 2, right? Just 3 over 2. And I don't see it anywhere. Alright, the sine inverse of 3/2 is undefined, or it does not exist. DNE stands for does not exist. Right? Remember, the sine function, the range of the sine function goes between -1 and +1. Right? For the inverse sine function, the domain of the inverse sine function is -1 to +1. So I can only do the inverse sine of numbers in between -1 and +1. Right? 3/2 is bigger than 1. Right? It's 1.5. Right? Well, 1.5 is like a y coordinate up here. Well, nowhere on the unit circle has a y coordinate of 1.5. Right? So the sine inverse of 3/2 does not exist. There is no sine inverse of 3/2 because there is no number that when I take the sine of it, I get an answer of 3/2. Right? When I do the sine of a number, it always gives me something between -1 and +1. Right? So there are a lot of values that you can't take the sine inverse of. Right? You can only do sine inverse of numbers between -1 and +1. Anything bigger than 1, anything less than -1, the answer just does not exist. All right, so there's a few examples there. I'm going to pause this. We still have a few minutes here. I'm going to pause it and put up a couple more examples where we do some more evaluating inverse sine functions. The more of these you see, the easier it becomes to figure out what they are. A couple more examples we'll go through real quick. We have sine inverse of -1. All right, so once again, when I'm doing these inverse trig functions, this is how I think about it. I see sine inverse. Right, so that tells me right away, right half of the unit circle. Sine tells me I'm looking for a y coordinate. And I'm looking for a y coordinate of -1. Well, that's actually the one closest to me right here. Right, that's where on the right half of the unit circle I have a y coordinate of -1. So sine inverse of -1 is negative pi over 2. Right, when I'm doing the inverse sine function, they're giving me the y coordinate of my terminal point. I have to find that pi number on that right side of the circle. That gives me that y coordinate. Right, and remember, we give the numbers in the fourth quadrant as negative numbers, not 3 pi over 2, but negative pi over 2. All right, sine inverse of root 3 over 2. All right, sine inverse, right half of the circle. Sine tells me the y coordinate. So where's the y coordinate? Root 3 over 2. That is up here at the value of pi over 3. And I think maybe we did that one earlier. Or I think maybe I did that one in the other video that I did where I explained the inverse sine function. All right, so sine inverse of root 3 over 2 is pi over 3. Right, and if you know the unit circle very well and you get the point where sine is just the right half and I'm looking for the y coordinate, doing these is easy because you're just looking at your unit circle and picking out where's this y coordinate and then you give your answer. It's really not hard to do. Right. Sine inverse of 0.82. All right, well, I'm looking for a y coordinate of 0.82 on the right half of my unit circle. Well, none of the numbers that I have up here on my y coordinates are 0.82. Right, that is not the case. So what I need to do is use my calculator in order to evaluate sine inverse of 0.82. All right, and we talked about this on one of the other videos I did, but make sure your calculator is in radian mode, which the mode button is on my calculator up here next to second. And you can see the third one down has radian and degree. So make sure your calculator there is in radian mode before you do this. And then to do sine inverse, right, if you look above where the sine button is, it has that sine -1. So that's my sine inverse function. So I do sine inverse of 0.82. All right. And I hit enter, and it gives me the value, which is 0.9614 approximately. So that's the sine inverse of 0.82. Right, to do the sine inverse of 1/3, I do sine inverse, so it's second sine on my calculator, and then 1 divided by 3. All right, and I get 0.33983, it looks like. It's hard to read that backwards, but I think that's what it is. Yeah. All right, so the sine inverse again, so it's above the sine button, and same for cosine and tangent, right? The inverses are like the second, and then those buttons. If you have a different type of calculator, the inverse sine, inverse cosine, and inverse tangent are going to be up there somewhere. You just have to figure out where they are. Right, but if you have to evaluate the inverse sine function, and it's not one of these ones you know from the unit circle, which is really only a few numbers that we have on the unit circle, the ones, the root 3 over 2, root 2 over 2, 1/2, and 0. If it's not one of those, then you use your calculator to do it, right? As long as that number is in between -1 and +1, you can get it from the calculator. All right, so that's evaluating inverse sine.